So from home, make sure na you click New Live Script. Then I'll just insert the question for this specific Matlab. So the question is, the following data were obtained for the reaction 3A producing 2B. We are given here a table that includes the time and the concentration of A, time in seconds, and concentration of A in molarity. And we are asked to determine the order of the reaction, but also we are going to determine the rate constant for this reaction. So let us start. Just make sure that you go back to Live Editor and you click Code. Let's just introduce first the given. So let's use lowercase t for time. Enclose all the data in a bracket and separate all the numbers by a comma. Then next is the concentration. I'll just represent concentration as uppercase A. Then again, input all the data and separate them with a comma. Let's just check if the codes are running. So here we can see the data for time and for the concentration of A. Then next, let's just use the variables x and y for our plot. So let's transfer the data for time to x. So x equals t, so that all the data we have introduced for t will be transferred to x. Then since y-axis for different orders of reaction will be different, let's use y0 for 0th order. For 0th order, the y-axis of the plot should be just the concentration. So this is just equal to A. For the first order, the y-axis should be natural logarithm of the concentration. So the code that we will be using for natural logarithm is log. So that should be log of A. Then for the second order, y-axis is equal to 1 over the concentration of A. And since this is a matrix, we have to put a dot before the division sign. Then we type A. Then let's check if it will be running. So here are all the data. For x-axis, it was just transferred from t, y-axis for 0th order, and y-axis for the first order, y-axis for the second order. Now we can start plotting. Let's use the variable p0 for the plot for 0th order. So we use the code plot, then x-axis, y-axis for 0th order. Then just to differentiate the three plots, let's just make the plot yellow. Then to adjust the thickness of the plot, we use p0 dot line width equals any number will do. Then let's check if the plot will appear and also the thickness will take effect. So this is now our plot. And just to hide all these information that we don't need for our plot, we just have to put semicolon at the end of our codes. So after that, we just put title for our plot. So let's use 0th order for this plot. Then let's also include the label. For x-axis, our label is time in seconds. Then for our y label, our label will be concentration of A in moles per liter. Then let's just include the grid. So type grid on. Then run again to see if there will be changes. So we now have the title, 0th order, x-axis, time, y-axis, concentration of A. Then since the codes for the plots for 0th order, 1st order, and 2nd order will be similar with each other, we just have to copy the code that we used for 0th order. Then just change 0 to 1 for 1st order. Then of course we have to change the color as well so that it would be easier for us to differentiate. Then our title will now be 1st order. Our X label will still be time, but our Y label will now be natural logarithm of concentration of A. Then run. Now we have the plot for the 1st order. And we just have to repeat the step for 2nd order. So we just replace 0 by 2. Then let's use G for green color. Then change the title to 2nd order. Change the label to 1 over the concentration of A. And of course the unit will be also different. It will be liter per mole. Then run again just to check. Then we now have the plot for 2nd order. Now that we have the plots for 0th, 1st, and 2nd order, we can now conclude our answer using fprintf, since we know that the order of the reaction based on the plot will be the one that produced a linear plot, so the answer will be 2nd order. So let's just say the reaction is 2nd order. And that will be our final answer. And as I've said, let us also compute for the rate constant using linear regression. So let's represent linear regression as LR. Then the code is polyfit. Then the x and y axis for 2nd order. Then we type 1 for linear regression. Initially, if we run this, we'll get the slope and also the y-intercept. Remember that in linear regression, it is in the form of slope-intercept form. Therefore, two variables can be computed, the slope and also the y-intercept. Since the slope is rate constant, that will be k. Then call out the first number in the linear regression, which is represented by the slope. And if we run this, we'll see that we have now k, which is the slope. And to conclude the answer for the rate constant, again we use fprintf. The rate constant is, then we simplify it to 2 decimal places. So we use %.2f. Then the unit for the rate constant in 2nd order is liter per mole per second. Then comma k, where the value will be coming from. Then run again to check if we have concluded the final answer. So we now have here the rate constant is 5.98 liter per mole per second. Before we save these exercise or activity, let's first include our name, but make sure when you include your name that you press or you click text so that it will not be read as part of the codes, and just type your name. Then just include your section. To generalize, let's just say IS 000. Then for a better result in our PDF file, when we publish the Matlab activity, make sure that we put section break in between the spaces that we created on our codes, especially between the different plots, to make sure that the plots will appear on our final published PDF file. So just put section break. Then after that, we can now save this. Click save, then just type your section, underscore, your surname, and your initials, dot m. And just click OK and wait. Okay, so this is what will appear after saving your Matlab file. Then we just click publish, then publish as PDF. And this will be the final file for our activity. And after that, you can just click download. So in this question, using the experimental data shown in the table, calculate the activation energy for the reaction to the nitrogen monoxide producing 2 nitrogen gas plus 1 oxygen gas. We are given 4 experiments, and we are given the temperature measured and the rate constant computed for every experiment. So let's start by introducing the data given. So let's use uppercase T for temperature. Let's just enclose all the data inside a bracket and separate them using a comma. Then for rate constant, let's just use lowercase k. Then again, enclose all the given inside the bracket and separate them using a comma. Let's check if it's going to run. Then we have here the data introduced for temperature and the rate constant. The next is, since we need to plot x and y, our x is equal to, based on our Arrhenius equation, that should be 1 over the temperature. But since, again, this is a matrix, that should be 1 dot, then division sign, then the temperature. Then for our y-axis, that should be natural logarithm of rate constant, so that should be log of k. Then let's just check if we'll get the data for x and y. So we now have here x and y. Then we can plot this. So we just name this. We just use the variable p1 for the plot. Then use the code plot. Then x, y, and let's use -o for the design of our graph. Then let's just increase the thickness. So that should be p1 dot line width equals 3. Then again, let's hide the properties using a semicolon. Then we now have the plot for our Arrhenius equation, or for the given data. Then we include title. Our title will be Arrhenius equation using linear regression. Then X label will be 1 over the temperature, which is 1 over Kelvin. Then our Y label will be natural logarithm of the rate constant. Then let's just put a grid. So type grid on. Then check again. So this is now the title, Arrhenius equation using linear regression, our y-axis, our x-axis. So for our computation, so since this is linear regression, let's use the variable LR equals, then polyfit x, y, and 1 for linear regression. Okay, so after using polyfit, we now have the slope and the y-intercept. Using this data, let's just use the term slope to separate slope from y-intercept. So our slope is the value from the linear regression, the first value from the linear regression. Then for our y-intercept, that is the value from the second linear regression. Then run. Then we'll see we have here the slope and the y-intercept. So to compute for the activation energy, just recall that the slope is equal to negative activation energy over the gas constant. So let's introduce the gas constant, which is 8.314. Then using the formula, deriving the formula for activation energy, that will be activation energy is equal to negative slope multiplied by the gas constant. And let's check if we'll get the activation energy. So now we have the answer for activation energy. We can now conclude our answer. So we use fprintf. The activation energy is, again, let's simplify our answer to 2 decimal places. We use %.2f. Then the unit for activation energy is joules. And the value is going to come from EA. So we now have our activation energy. Let us also compute for the frequency factor. So the frequency factor can be computed from the y-intercept. So remember that the y-intercept is equal to natural logarithm of A, which is our frequency factor. So to compute for the frequency factor, that will be A is equal to exp of the y-intercept. Then let's run. And we now have the frequency factor here. And we can conclude our answer for frequency factor using fprintf. Frequency factor is, again, let's simplify our answer to 2 decimal places. We use %.2f. Then the unit is liter per mole per second for frequency factor. And let's call out the value from A. And we now have the answer for the frequency factor. Then just like we did with the first example, we include our name. but make sure it is in text. Then the section, let's just have another arbitrary section. Then don't forget to use section break in between the spaces of our codes. Then after that, we can now save the activity. So section underscore the surname, then the initials .m. Then just click OK. And wait for this to appear. Then again, click publish as PDF. Then just wait for your PDF to be ready. So we now have our final file for our second activity. Then again, you can just download this before passing your activity.